Hey guys, so let's work it out. We have quadratic functions now. And remember, we are still talking about inverse functions. So yeah, inverse functions. Let's dive in. So Nerubua, we spoke about linear inverse functions earlier on. And one thing I want you to know from the linear functions is that, or something that we mentioned on that video, is that the inverse functions, like, bro, it's always the same, ne? You have a function, it doesn't matter what function it is, quadratic, um what is this again, linear. Okay, for hyperbola it matters. Does it necessarily matter? I don't think so. Exponentially, all these, ne, method is the same method. Yeah, so if you're trying to find the inverse function, basically you swap x and y, and then you solve for, yeah, okay, if you swap x and y, then you're gonna solve for y. But then if the first step you do is to write x as the subject of the formula, then later you will swap them. Wow. Yeah, but it's just all about swapping x and y, right? Say for example you have this function which is f of x, and what did I say? Okay, and for the inverse of these functions, ne, equals to f of x. For the inverse of these functions, for example this one, when you try to solve for x here, no, when you try to find the inverse, you could try to write it, write x being a subject of the formula. So in that sense you have, no, this doesn't make sense, so 0 is fine. You would have 8x squared 4y, right? And then divide by 8, and then you have x squared equals to 1 over 2y, and then you would say therefore x is equals to plus or minus square root of 1 over 2y. And then after that you would then say therefore f of x, the inverse will be plus or minus square root of 1 over 2x. Ne? So here I started first by solving for x, make x subject of the formula, then later on swap x and y, right? Of which another person might be comfortable with the idea of, okay, let me say I have 4x equals to minus 8y squared, right, equals to 0. So then from here we have 8y squared equals to 4x, y squared equals to 4 over 8x, and then they will say square root of y squared equals to square root of 1 over 2x, x plus or minus, by the way. So then you have y being plus or minus square root of 1 over 2x, which is exactly what we have, right? Then here, to show that this is an inverse, plus or minus square root of 1 over 2x, right? Cool. So yeah, that is it. And just like this, but you have found the inverse function of the parabola. And something I want to show you guys about the parabola, ne? Oh, by the way, I'm remembering there was a theory that I mentioned, but I never tested it out there. Can we go back to linear functions? So let's focus on the, which color, the blue one. That was our original function, and I was like, so okay, this was 1. Okay, let me use which color. I don't know which color would stand out. This is 1, and this is 1 over 3. Yeah, so I was like, this day when you swap it like this, ne? When you swap it like this, and this becomes your y, this becomes your x, ne? You end up having the x value is 1, right? Here's the x value and it is 1. And by the way, this is our working for the inverse, I remember, and that was y. And then the y value, we have it here, right? Oh, but interestingly enough, here the y value is on the side, which must be negative. So yeah, let me see. Okay, so apparently that theory, we have to throw it away. I was just saying, like, I have this idea that an inverse function, right, is when you just turn your Cartesian plane like this, or perhaps you swap your x for x's and y axis, you'd have your inverse function. But that is not it. Yeah, cool. Let's work on the rest. Before we go to the rest, I want to say this. For parabola, you guys know, parabola would look something like this, or it will look something like this, Now, when you plot the inverse function could look something like this, right? Or something like this, right? Of which you would realize that if you use the vertical line test, it will fail, because this x value would have the same y value here, and no. This one x value would have many y values. The same is true here. One x value, many y values, right? So the vertical line test, it will fail. So usually we would restrict the range to say, can you plot the inverse function of this parabola for y is greater than this value, or for y is smaller than this value? So when we restrict the the y values, right, we make it such that it will look something like this, right? It will look just like the green part. So when it looks as just the green part, then it passes the vertical line test. You see, we can do something like this, right? And then yes, it does pass the vertical line test. You see, then it qualifies as a function, right? We can call it a function to say, okay, this is a function, right? So yeah, one thing I will say is, look, bro, I don't think this is something difficult. It's something you can do by yourself. When it comes to plotting the functions, it is very easy. So because you just basically, if you struggle, bro, the easiest way you can plot a graph is you draw a table with a couple of x values, and then fill in the y values. You use your calculator to get those y values, and then you plot them. That is very easy. I believe in you guys, you can do that. So I'm not gonna do it on these videos, yeah, I'm not gonna do it unless we have an exam question saying do it, then I will do it. Cool. So we're still finding the inverse functions for the parabola here. Remember, let's swap first. So when you swap, you would have I think maybe black is fine. 4x minus 9 equals to y plus 3, y minus 3, right? And then now I have to solve for this y subject of the formula. This side I'm gonna have y squared minus 9. That was just the difference of two squares, 4x, right? And therefore I'm gonna have y equals to 4x minus 9 plus 9. Oh no, for x squared. And then here, right, those they cancel, and then I have y squared. So therefore y is equals to plus or minus 2 square root of x, right? So you can either focus on y being plus square root of 2x, no, 2 square root of x, or y being minus 2 square root of x, right? Then yeah, you just limit the range, then you're good. We go here is the same thing. So technically this subject would look something like 5y equals to x squared, y equals to 5 equals to x squared over 5. the function would look something like this. So but now when we are solving for it, trying to find the inverse, here we swapped. Here let's not swap, let's make x subject of the formula. X equals to, damn, this one is gonna be x squared is equals to minus 5y. Ooh, yeah, this one, it looks juicy. Because for example, the next step would be x is therefore equals to plus or minus square root of negative 5y. This one looks juicy, bro. This one, it looks how I'm thinking of a trick, because I'm thinking this is going to be invalid for positive y values, right? It's gonna be invalid, so we will then choose it for negative y values. Yeah, okay, let's do this. Let's say we swap x, so we have x squared, no, we have y squared equals to minus plus 5x equals to 0, and then so now we swap x and y, right? After swapping x and y, because this thing is gonna be a square root of a negative value, right? So I think okay, I got it ne? So let's do it either way. Right, let's do it either way to say minus 5x ne? And then say therefore y is gonna be plus or minus square root of minus 5x wobble. Then you say x smaller than 0. Then when x is smaller than 0, we know for sure that whatever is going to be inside here is going to be positive, because negative and negative, positive. Then you have a square root of a positive value, right? Yeah. Yeah, and then plus or minus square root of negative 5x, x is smaller than 0. Anyway, this is the parabola. Let's close it here. So I was not aware actually that I had an extra question for parabola. So yeah, parabola is still continuing just a little bit. So let's see, given the graph of a parabola, cool. So you have a graph of a parabola there, and then for x is greater than 0, so passing through the point. Cool. Determine the equation of the parabola. Okay, cool. So here easily you just say substitute x and y, so you have minus 3 equals to a x squared. No, this becomes 1 squared, and so therefore a is minus 3, and therefore y equals to, or you'd say f of x equals to minus 3 what, x squared. And then they say state the domain and the range of this function. So you see the domain, for domain, right, domain, it will be from 0 to positive infinity, because they're saying that with x greater than 0, so that's the domain. And then for the range, we are moving from 0 going downwards. So for the domain, for the range, right, for the range, you would say that y is an element of numbers from 0, from negative infinity to 0, because remember, we always start with the smallest, so it goes from 0 to negative infinity. So yeah, so the range will be from negative infinity to 0. And then give the coordinates of the point on f minus, right? This is the inverse that is symmetrical to point P. This is beautiful. Now they're asking you exactly what you know, because what do you know? You know that on the thing, the values they swap, right? the values they swap. So that point is gonna be minus 3 and 1. That you know for sure, right? But yeah, alright guys.